Okay, this is Chapter 9, where we are focusing on intelligence and psychological testing. There are a couple key questions that we want to focus on during this unit, which is, can we define intelligence? Can we measure intelligence? And then what is responsible for our intelligence? Is it something that is in our genes and our DNA, or is it a part of our environment? So to kind of talk about, to give a fun introduction to that whole idea of, can we define or measure intelligence, I wanted to share with you a small little clip from The Big Bang Theory. Just a little background on The Big Bang Theory, if you haven't seen it before, is you have two characters, Leonard and Sheldon, who by most accounts would be considered highly intelligent. They have IQs well over 130, which ranks them as gifted. They're physicists. Their vocabulary, their achievements, by all means, makes it seem as if they are highly intelligent. So this clip is just focusing on which one is actually smarter. So take a look.
Okay, new contest.
What are you doing?
I am settling once and for all who is the smartest around here. Okay? Are you ready?
Absolutely. Bring it on.
Marcia, Jan, and Cindy were the three daughters in what TV family? The Brady Bunch. Okay. Sammy Hagar replaced David Lee Roth as the lead singer in what group?
The Brady Bunch?
Van Halen. All right, Madonna was married to this Ridgemont High alum. Oh my God, Sean Penn!
How do you know these things?
I go outside and I talk to people. Okay, here. What actor holds the record for being named People Magazine's sexiest man alive?
William Shatner. I don't think it's Shatner. Then it's got to be Patrick Stewart.
No.
Formal protest.
All right, singer who sang Oops, I Did It Again? Okay. Tweety Bird taught he taught a what?
Romulan.
Yes, he taught a Romulan.
So that clip just kind of brings up the question of how can you be so intelligent in one area and then maybe not in another? And to be intelligent, do you have to have knowledge in all things? And this is just something we're going to continue to ask as we go through this chapter, and again focusing on how to test and define intelligence. All right, similarly, I love this quote by Albert Einstein. Everybody is a genius. But if you judge a fish by its ability to climb a tree, it will live its whole life thinking it is stupid. Again, as we move forward and we talk about what intelligence is and what it is not and how to measure it, this is something to keep in mind. Are the ways that we are coming up to measure intelligence actually valid measures of what it takes or means to be intelligent? Okay, so when we talk about psychological testing, there are two different types of psychological tests that we use in the field of psychology. One is mental ability tests. Mental ability tests are exactly that. We are testing some aspect of your mental or cognitive abilities. Some examples of those would be just actual intelligence tests. Some of you maybe have taken one, maybe in elementary school. We also have what we call aptitude tests. Aptitude tests are tests that are assessing your potential for some thing in the future. So for example, taking the SATs is an example of an aptitude test because what they're testing is your potential in college. I'm not sure if you're aware of that or not, but the SAT scores are actually used to predict what your GPA will be within that first year of college. The other type of mental ability test is an achievement test. An achievement test is a test designed to see how much you have achieved, how much knowledge you have gained. So our AP exam that's coming up in May is actually an achievement test. It's designed to see how much have you achieved in the field of psychology. The other type of psychological test is personality tests. Personality tests are used to measure a variety of traits. In other words, we're trying to assess how extroverted you are, what motivates you, what interests do you have, what are your values, what are your beliefs. These type of tests do not have right or wrong answers. They don't give you necessarily a score. It more just gives you feedback on which qualities or traits that you have or that you possess. Now, if we focus on those intelligence tests, how can we assess intelligence? Well, in order to be accurate with our testing, the first thing is all tests must be standardized. What that means is that when you're administering a test, you have to make sure that you have uniform instructions and procedures for all who are taking the test to ensure that you can compare one another's scores. So, for example, when you take the SATs or even when you take the Keystones, you always have that proctor who's in the front of the room who's reading those directions about find page 10 in your answer booklet and find page 5 in your test booklet. And while you're probably rolling your eyes as they are reading those instructions, every proctor has to read the same exact thing to make sure that all students taking that test get the same instructions. Therefore, their scores can be compared. The other thing is for any psychological test, we want it to have reliability. What that means is the test must give consistent results. If you test and then you retest, the scores should be similar. So when you take the SATs, if you take it a second time, your score should be similar to the first time that you took it. Certainly there's room for improvement, but for the most part there's consistency in scores, and if that occurs, that means the test has reliability. And then the last thing we want to see in tests is that tests have validity. In other words, tests measure or predict what it was designed to test and predict. In other words, we want the test to be valid. Is the test testing the thing that we are measuring? Okay, there are 3 different types of validity that you need to be aware of. The first is content validity. Content validity is when the content of a test is representative of the domain it is supposed to cover. In other words, if I'm giving you a test on, say, Chapter 6 learning, right? The orange circle represents everything that was in Chapter 6. Your test needs to come from that domain. In other words, I need to test you on those things from Chapter 6 and not on some other domain. That's content validity. Criterion related validity is the relationship between the test score and some other outcome. In other words, does the test predict the behavior that it was designed to predict? So if you have a written test that you want airplane pilots to take, does their score also correlate with, say, their performance rating when they actually fly the plane? In other words, is the test a valid indicator of how well they will fly a plane? You could even use this for your driver's license test. Is that criterion related validity? In other words, does the driver's written portion of the test predict how good of a driver you will be on the road? And the last is a construct validity. Evidence shows that a test measures a particular hypothetical construct. In other words, there are certain things that we're trying to test for that are, again, hypotheticals, things we can't actually see, things like intelligence, anxiety, your motivation. So we want to try and have tests that, again, are measuring those constructs. Another example of criterion-related validity would be SAT scores and IQ. If you take a look here, we have a correlation, a positive correlation between IQ and your SAT scores. It seems that the higher the IQ, so as IQ increases, so does the score on the SAT test, which then is saying that that your high IQ would predict a high SAT score. Therefore, the IQ test and the SAT test both have criterion-related validity. All right, everybody. So we are going to take a test here, an IQ test. It's called the Morris Shoe Size IQ test. So here's all I need you to do. Step 1, take your shoe size. All right, so I'm a size 7. Step 2, multiply that by 10. So that would give me 70. And then your answer is your IQ score. Easy enough. So my IQ score would be a 70. All right, now repeat those steps a second time. Okay, so take your shoe size, multiply it by 10. Your answer is your IQ score. Did you get the same result the second time? Of course you did, which means that this test is reliable because the retest provided similar results. Does the test actually measure intelligence? Obviously not, right? It's measuring your shoe size times 10. That's not intelligence. Therefore, the test is not valid because it does not actually measure intelligence. All right, let's try another test. This is called the t-test. You will have 15 seconds to write as many lowercase t's as you can. So if you need to, press pause, get yourself pen and paper if you don't already have it, and then come on back. And I have my timer, so I will time you. For 15 seconds, I want you to write as many lowercase t's as you can. Ready, set, go. Time. Okay, so go ahead and count up how many T's you got. And again, if you need to, hit pause. Once you have your answer, we're going to go ahead and try that again. All right, ready? So let's do the test over again. Another 15 seconds on the clock. As many lowercase t's as you can, and go. Time. Okay. So, did you do better the second time? A lot of times what people do is they just write straight lines and then they take one big horizontal line across and they end up getting a whole lot more little t's. So the question becomes, did the test measure intelligence? And did the retest provide consistent results? In most cases, you're probably answering no for both of those questions, which means that the test is not valid and it is also not reliable. This image provides us a great classic example of reliability and validity. So if we take a look at a bullseye target, if you look at this first example, you could see every time the person shoots the arrow, they're pretty much hitting in the same location. That's consistent results, so it's reliable. However, we're not getting on that bullseye there, so it is not valid. If you have this target here, and you can see the dots are all over the place, showing that this is low validity, also low reliability, because we're not getting consistent results. Here we are not getting any reliability, right? And also still not getting that validity. And then finally, we're getting some consistent results here where we are hitting that center target, which means we're measuring what we're actually trying to measure. And so this is both valid and reliable. All right.